This is the third and final video for Module 1. And in Module 1, Section 3, we are going to discuss decimals and percents. So just like fractional notation, just like when we dealt with fractions, decimal notation is used to denote a part of a whole. The place value chart shown below shows the value of each place. And this would be something you may want to print off. You may want to pause the video and write this down because it's important to know. Let's circle the decimal point in case you can't find it. Here is our decimal. And as we go to the left of the decimal, those are our whole number parts. We have the ones place, the tens place, the hundreds place, the thousands place, and so on. Now going to the right of the decimal point, that's when we have the decimal notation. And you'll see that the places are similar. We don't have a ones place to the right side of the decimal. We start with the tenths. Then we go to the hundredths, the thousands, the 10,000s, and so on. And you can see with each of these decimal places, we have a fractional representation. The tenths place, if I have 1/10, that can be represented as a fraction. 1/100th, 1/1000th, and so on. So let's try to do that. Let's try to write decimals as a fraction. And the way we will do that, it's very important to know how to read the decimal, to know what decimal place we are ending the number in. So I'm going to underline the 9. And we know that the first place to the right of the decimal is called the tenths place. Whatever place we end the decimal in, that will be the number that goes in the denominator. So for example, 0.9 equals, because the 9 is in the tenths place, we rewrite this fraction as a number over 10. And then the number that goes on top is the number that's represented in the decimal. So we have 9 over 10, or 9/10. Let's try the next example. We have 21.094. The 0 is in the tenths place, the 9 is in the hundredths place, the 4 is in the thousandths place. So the way we would read this is 21 and 94 thousandths. Because our decimal ends in the thousandths place, our denominator will be 1,000. The numerator, just like before, we write the entire number that we see from the decimal representation. 21094. We're going to write what we had without the decimal. The decimal is taken care of by rewriting this as a fraction. And so we have 21,094 all over 1,000. Now we're not going to spend much time on adding or subtracting decimals. You can see in the steps here in the PowerPoint. You can write these steps down. You can print this PowerPoint slide for your own information. I know many of you are just going to use the simple calculator in order to add, subtract, multiply, or divide decimals. And since we provide that, that is perfectly fine. If you would like to know how to add or subtract decimals without a calculator, you can do that as well. This is another example that goes a little further into that process. Again, multiplying and dividing decimals, we're not going to spend much time on that process. So you may want to pause and read over these slides if you feel like that's something you should know. It is perfectly fine if you decide just to use the simple calculator to perform those operations. Now let's talk about rounding decimals to a specific place value. This is a two-step process. Step one, and this is very important, this is the part where most people have trouble, if they have any trouble at all rounding decimals. We have to locate the correct digit. If we want to round to the tenths place, we have to be able to locate the tenths place. If we want to round to the hundredths place, we have to be able to locate the hundredths place, and so on. Once we locate the correct place, we want to look at the digit to the right of the given place value. So we locate the place that we want to round. We locate the location where we want to round, and we look at the digit to the right of the given place value. If that digit is 5 or greater, we're going to add 1 to the digit in question. Once we do that, we will delete all digits to its right. If the digit is less than 5, we're going to keep that place value the same, and we will still delete all digits to the right of that given place value. Let's try a few examples. Let's round 0.5942 or 5,942 ten-thousandths to the nearest thousandth. So we need to be able to locate the thousandths place. 4 is sitting in the thousandths place. I'm going to go ahead and circle that number. The digit to the right of 4 is 2. So we need to decide if that 2 is going to round our number up or not really down, but keep it the same. And so because 2 is less than 5, 4 will stay the same. So we'll write 0.594. And remember, once we round, we delete every digit to the right of the place value in question. So the 2 is gone. If there were numbers to the right of 2, they would be gone as well. So we have rounded to the thousandths place. Let's try another example. Round 0.067 to the nearest cent. If you know where the nearest cent is by looking at the decimal, that's great. The cent is going to be the equivalent to the hundredths place. So let's write our number, 0.067. The hundredths place, the first place to the right of the decimal is the tenths. The second place to the right of the decimal is the hundredths place. So I circle my number that's in the correct place value. And then I look at the number to the right. I look at the 7. And 7 is going to round my 6 up, or again, it doesn't round it down, but it could keep it the same. And that's what I'm using the down arrow to represent. Because 7 is higher than 5, it's 5 or higher, it will round 6 up. So 6 rounds up to 7. Let's write that, 0.07. So we round it up. And every number to the right of our rounded value is deleted. So 7 is deleted. If there were more values to worry about, they would be deleted as well. So we rounded to 7 cents. Okay, we try another example. An aquarium costs $245.69. Round the price to the nearest dollar. So now we're not being asked to round to one of the places to the right of the decimal, but one of the places to the left of the decimal. The nearest dollar, this would be the ones place. So we see that the nearest dollar means the ones place. We locate the digit to the right of the ones place. I'm going to follow the same process I have before. I'm going to circle the ones place, underline the digit to the right, the 6, and that 6 is going to round my circled number up or keep it the same. And that's how I use the down arrow. Well, because 6 is greater than 5, it's 5 or greater, 6 will round my circled number up. So I write 2, 4, 6, and every number to the right of the rounded number is deleted. The 6 is gone, the 9 is gone. If there were more numbers to the right, they would be gone as well. So $245.69 rounds to $246 if we round to the nearest dollar. We can also write fractions as decimals. You won't see much of this in the homework, so I'm not going to spend a lot of time going through this process. Essentially, if you remember, a fraction is a quotient. It is a division problem. The number in the numerator, we wanted to set this up like long division. The number in the numerator would go inside the house, number in the denominator would go on the outside, and that's how we would set up long division. Another way to write this is 4 divided by 5. And either way, working these out, either by long division, by working the division in the calculator, we could take the fraction that is given and rewrite it as a decimal. Here's an example of that process. Again, I'm not going to spend much time on this because most times in mathematics, especially this course, we would rather see the answer written as a fraction than as a decimal, especially when it's possible that the decimal that is given will be a repeating decimal that never has an end. Writing a percent as a decimal. The way we do this is by replacing the percent symbol with its decimal equivalent, 0.01, and then we multiply. Another way to think of that is moving the decimal point 2 places to the left. Either way is fine, whatever you would remember to do. We can either remember to move the decimal to the left, or we can remember to multiply by 0.01. Let's try an example, or a few examples of that. So let's write the percent as a decimal. If we start with 49%, the first thing we really need to do, if we want to use the trick where we are moving the decimal, is to be able to locate the decimal place. When we're given a whole number, such as the case of 49%, the decimal is located to the right of the ones place. 49 is in the ones place, the decimal is located to the right. Remember, using the process that was explained in the previous slide, we can move the decimal place twice to the right, twice to the left. 1, 2. So my new decimal place is in front of my 49. So my answer would be 0.49 or 0.49. Either way would be perfectly fine. Let's use that same method for the next example, 3.8%. So I write 3.8, and I want to move my decimal place twice to the left. 1, 2. Now, as we do so, we see we have a gap between our decimal place and 3. Any gaps that we have between the decimal and our numbers, once we've moved the decimal place, we will fill in those gaps with zeros. So the answer becomes 0.038. You may also see it written as 0.038. We don't have to write the 0 in the ones place, but you will see in some places that is preferred. So that's how we use the decimal moving technique. If we decide not to use that technique, we can replace the percent sign with the decimal equivalent, just like we saw from the last slide, which was 0.01, and we multiply. 185 times 0.01 is 1.85. So whichever process you prefer, multiplying by 0.01, moving the decimal place, it's exactly the same thing. Let me also mention that multiplying by 0.01 is the same thing as dividing by 100. When we want to go from a percent to a decimal, we can take our number and divide by 100. It may be easier for you to remember than multiplying by 0.01. And we have one last example. Let's take 0.69, replace the percent symbol with 0.01. And when we multiply those two numbers together, we will get 0.0069. And again, the leading 0 in the ones place to the left of the decimal is not necessary, but it's okay if you include that in your answer. Well, if we can write a percent as a decimal, we can also write a decimal as a percent. We do this by multiplying 1 in the form of 100%, or we move the decimal 2 places to the right. So it's exactly the opposite of what was being done in the previous examples. So let's try both methods. Let's first try the decimal place method where we're moving the decimal 2 times to the right. Then we'll try multiplying by 100 and see that the exact same thing happens. So whichever process you like better, you can use that. So we start with 0.26. If we want to write that as a percent, we take 0.26 times 100%, and that becomes 26%. We can also use the multiplying by 100 method for the next example. 1.46 times 100% becomes 146%. Let's try that method one more time. 50 times 100% becomes 5,000%. For the last two examples, D and E, let's try the method where we move the decimal place 2 times to the right. Remember, that's exactly the opposite direction that we moved the decimal when we were trying to move from a decimal, from a percent to a decimal. So we start with 0.7. We move the decimal 2 times to the right, 1, 2. Remember, if there are any gaps between our numbers and our decimal place, we fill in those gaps with 0. Now the leading 0 here doesn't make sense to keep any longer. The 0 furthest to the left. So our answer, we start with a 7. We have a 7. We have a 0. And then we have the decimal point, and that's just 70. Let's go to the last example on this page. 0.061. We move the decimal 2 times to the right. 1, 2. No gaps that need to be filled in. We ignore the leading zeros and we write 6.1. One thing I forgot to write on the 70 is the percent symbol. We're writing as a percent. So this would be 6.1%. Those are all of the examples that we're going to work through with decimals. Make sure to watch these videos as many times as necessary and ask questions if you have them.